Thank you very much for attending tonight's workshop. I know it has been a long day, and we have together been engaging in one long, wonderful conservation dialogue here in Jeju over the past few days. So I would like to get the workshop started. I know there are a few people still in the queue for beverages and food, and that's great. Please take what you would like and, to eat and drink, and then please take your seats, and we'll get started. My name is Rob Brumbaugh. I'm a scientist with the Nature Conservancy Global Marine Program, and it is a real privilege to introduce this workshop and to have co-organized the workshop with a number of other people that you will hear from this evening. I want to really thank you all, not only for being here, because we ordered catering and we were afraid that there would be no one to enjoy it. So we really appreciate you showing up here at the end of the day. But also, I'd like to thank you for being active participants in tonight's workshop. This is going to be perhaps a little bit different in that about halfway through, we are going to ask you for your opinion and your ideas, and we're going to ask for that in a very interactive way. And you'll learn more about that in just a little while. I would also like to thank my co-organizers and the speakers for their input on the program tonight and their insights and their expertise that they bring on a variety of different types of coastal wetlands around the world. So it's a real privilege to actually spend some time learning from each of them. And because this is going to be a little bit of an experiment in the way we facilitate the discussion later on, I have to thank in advance the fearless facilitators who are going to help with that. They may not be talking to me later, so I would just want to thank them now. The goal of this workshop is to learn about different kinds of coastal wetlands. And we're going to learn from 5 speakers who will present brief presentations about their particular place and type of wetland and the challenges and successes that they're experiencing there. But what we would like you to do with that information then is think about opportunities to promote the wider conservation and restoration, especially, of coastal wetlands. We're finding restoration being a more and more common theme in the Congress this week. So, without further ado, I'd like to turn this over to our first speaker, Klaus Schmidt from GIZ. And Klaus will be giving us a presentation about mangrove restoration.
Thanks, good evening. I've been given 10 minutes. I could use all the 2 hours, so therefore bear with me. I will be very brief and only touch some important points on practices and challenges in mangrove restoration. As Robert already said, my name is Klaus Schmidt, and I'm the Chief Technical Advisor of the GIZ project, which is called Management of Natural Resources in the coastal zone of Sóc province in Vietnam. Now, let me tell you what mangroves actually are. They are the characteristics of littoral down formations of tropical and subtropical sheltered coastlines. It means they grow in the intertidal zone. And as you can see on this map, everything which is green are mangroves. This gives you an idea about their distribution. And now, worldwide, we have an area of about 140,000 square kilometers. The numbers vary a little bit in the tropics and subtropics in 118 countries and territories. What is very important when you talk about mangroves is to understand that they're dependent both on terrestrial and tidal waters for their nourishment. They need salt water and fresh water, and they need silt deposits from upland erosion as substrate for their support. What is so interesting about mangroves is that they provide a very wide range of ecosystem service, and that makes them so important, including carbon sequestration and coastal protection. I would like to spend a moment talking about these ecosystem services, not all of them because it takes too long, just give you 3 examples. Mangroves store up to 50 tons more carbon by area than tropical forests, and the term blue economy has been created recently, which covers all the other ecosystems about which you will hear today. About 75% of all tropical commercial fish species spend part of their lives in the mangroves. Mangroves provide nursery ground, shelter, and food. Without mangroves, there are no fish, basically. And mangroves attenuate wave energy, as you can see in this picture. They protect the coast from erosion, but also from strong winds. Now I want to capture this in two actual figures. One figure is simple to remember. Basically, each hectare of mangrove destroyed means a loss of 1 ton of fish catch per year. Another figure from Vietnam, 1.1 million US spent on mangrove restoration in the north of Vietnam, saved 7.3 million US dollars annually in dike maintenance. So this highlights the importance of mangroves. But we have threats, and what are the threats? First of all, between 1980 and 2005, about a fifth, about 20% of mangrove covers were lost worldwide, with Asia suffering the largest regional net loss. There are mainly anthropogenic causes, which are the main driver of change, but to a certain extent also storms and tsunamis. Now I want to give you some of the examples which have caused these changes. Coastal development, urbanization, agriculture and aquaculture. Here's an example. Oh, it's a bit too much light. You just must believe me. Basically what you see here is shrimp ponds eating up the mangrove forest, which is unfortunately quite dark. You probably can't see it very well. There's tree cutting, dumping, pollution, and so on. River discharge changes and changes in hydrology. And there's another threat, which is global warming and the resulting sea level rise. And I want to be a bit provocative. What you see on this picture is a dynamic equilibrium, something which you find very often along dynamic coastlines. This is an island in the north of Germany, and this island is flooded constantly by the sea. It has no dike, but because it's flooded, there's sedimentation. So we have a sedimentation rate of about 45 millimeters per year, and at the same time you have a sea level rise of 45 millimeters, and so we have a very dynamic equilibrium. And I say that in some sites, not everywhere, where you have mangroves, a similar thing may happen, because mangroves colonize newly accreted land. And once they colonize this land, they actually accelerate the trapping of sediments, and they raise the land. And so if we don't change the hydrology, if we don't change the discharge regime of rivers by putting dams in certain sites, maybe the land which is trapped and created by mangroves will offset, will compensate for sea level rise. Now, the other topic now is restoration of mangroves. In a nutshell, planting mangroves is extremely simple. What you see on the left-hand side is a propagule. That's how mangroves, some species, propagate. You just take them and stick them in the ground. I'll give you one example. In Pakistan in 2009, within one day, more than 500,000 mangrove saplings were planted. Part of it was entered in the Guinness Book of Records. It just shows how easy it is. There are a lot of techniques available for mangrove restoration, including individual protection of tree species by bamboo or leaf boards, whatever. But what is very important, that restoration must be done site-specific and appropriately. That means you have to consider hydrology, the right species, the right planting time, techniques, and so on. But despite all this, the ease of planting, the vast knowledge about different techniques, mangroves are still being degraded. And one of the main reasons for that is that planting alone is of little use. What does this mean? In addition to the planting, afterwards we need long-term protection and sustainable management. Because if you don't protect the plants, they will be gone again. We need benefit sharing and integrated approach to management. We have heard about it in many other presentations, ecosystem-based approaches. Now, what also helps is when we look at restoration management, when we look at innovation. I've said it before, but I have to repeat it again because it's important. We need different site-specific and appropriate solutions. And because we're dealing with uncertainties in the context of climate change, we also have to look at risk-spreading strategies. And there, innovative approaches help. I want to give you just two examples. One is mangrove restoration where we mimic nature, where we learn from the successful regeneration of nature. We don't plant mangrove trees like a forester, one plant every meter. We plant trees like you can see on this picture, very close together, close to establishing trees. This is not a large-scale solution, but for certain sites where we have higher wave energy, this might be a solution. But we also need to look for solutions to mangrove management. And one possible solution is co-management, involving local communities in a partnership agreement in which a resource user group gets the right to sustainably use natural resources, mangroves, on a defined area of state-owned land, while being responsible for the sustainable management and protection of these resources. I'll talk a little bit about this mangrove co-management. And basically, what it is resource users and local authorities negotiate a formal agreement on their respective management roles, responsibilities and rights. It's joint management. And you have to believe me now, because I don't have time to give you all the details, the monitoring which we have done, the data collection, but based on 3 years experience from Vietnam, I can say co-management is an effective way of maintaining and enhancing the protection function of the mangrove forest belt. At the same time, co-management provides livelihood for local communities, and also co-management contributes to better governance. And therefore, despite all this which I've said before, despite these ongoing threats, there's hope for the future. I think we can say worldwide the value of mangroves is gaining recognition. The value for coastal protection, the value for fisheries, the fact that blue carbon is becoming an issue, but also very recently, Mangroves for the Future has prepared a call for action for CBD COP11. These kind of initiatives are an indication that mangroves are gaining more and more in value. These are more international issues. I want to give you one example about how the value is also recognized locally. And this is from Vietnam, where I'm working. It's about benefit sharing through payment for ecosystem services as part of the integrated approach to coastal zone management. We have a situation where we have mangrove forests with all its related ecosystem services, and in front of the mangrove forest we have the mudfloods. On these mudfloods we have established a clam cooperative, and the local people, they recognize the value of mangroves. They realize without the mangroves there will be less clams on these mudfloods, and therefore, because co-management is managing the mangroves effectively, there are non-monetary benefits flowing to the mudfloods. They have more clams, and they have recognized this and agreed as a result to pay in terms of monetary benefits from their profits to those people who manage the mangroves. Well, this is a sign that even at the local level, people recognize and know about the mangroves, the value of mangroves. Now, I have only 10 minutes, therefore, very quick a summary. As I hope for the future, you can see it on this picture. But basically, the key issue is we need site-specific, innovative, and appropriate solutions for planting and management. And you may have noticed I've said this 3 times, site-specific and appropriate, because it's extremely important. We need community participation and an integrated ecosystem-based approach. We need sustainable financing, and the values and the importance of mangroves are gaining more and more recognition, and there's, in my opinion at least, light at the end of the tunnel. Thank you very much.
Thank you, Klaus. That was excellent. I will give a brief presentation on.
Can I just ask a favor? There are interpreters translating you. Can you please slow down, all of you?
All of us.
Thank you very much.
Indeed. Thank you for that.
That's just the problem, is 10 minutes.
Well, that's right. I've forced people into 10 minutes. I will attempt to be kind to the translators and thank you for helping us communicate. So my presentation on bivalve reefs, oyster reefs, mussel beds, and the like is actually summarizing a body of work that many people, more than I can possibly show on a slide, have contributed to over the past, well, really century. But these are folks that we've been working with just in the past few years to better understand oyster reefs and other kinds of bivalve reefs and their importance as coastal ecosystems. And we have to thank our funders, without whom we wouldn't be able to do any of this work. So I mentioned earlier that we've heard restoration, the word restoration, in this Congress frequently. And I think that's a really exciting thing for marine conservation. Increasingly, we're finding guidance on how to do restoration, whether it's bivalve reefs or the mangroves that Klaus just spoke of, or coral reefs, or specific kinds of corals. But what I think is really exciting, and this is something Klaus also mentioned, is that increasingly we're finding that there are international policies and frameworks that are helping to elevate the importance of coastal wetlands. So the Ramsar Science and Technical Review Panel recently published a briefing note on the benefits of wetland restoration. And just a few days ago at this Congress, IUCN and its partners published some guidelines for how and when to do restoration within protected areas, and noting that it was important to do so. So a little bit about bivalve reefs. Like mangroves that you've just heard about and other kinds of coastal wetlands that you may be familiar with, bivalve reefs are important ecosystems in the coastal zone. Bivalve reefs are ecosystem engineers in that they literally create three-dimensional structure by accumulating in reef-like configurations shown on this slide from different places around the world. So these are species of oysters, but also mussel beds form bivalve reefs, for example. That physical change to the environment makes them engineers. Not only does that benefit the oysters or the mussels themselves, but many, many other species. And so many of the same ecosystem services and benefits that Klaus mentioned for mangroves are provided by oyster reefs, for example. One of the challenges, I think, is that we tend to manage bivalve reefs only for the extraction of the bivalves themselves, and we fail to manage explicitly for the many other services that are listed on this slide, like improving water quality by filtering water and making it clearer, like removing nitrogen, which can be a pollutant in many urbanized areas, like stabilizing shorelines and protecting other kinds of wetlands like salt marshes or people and the infrastructure that lies behind them. Those are ecosystem benefits that we have only recently begun to appreciate for bivalve reefs. For thousands of years, hundreds of thousands of years, really, people have consumed bivalves, and they've been an important part of our diet and our culture. In the southeastern United States, for example, native people in North America literally built their villages on mounds of billions of shells of oysters that they harvested from nearby coastal waters. Even millennia later, just 100 years ago, we were still building houses in the coastal zone using oyster shells as the building material because there are no rocks to speak of, or not many, in this part of the world. So in addition to being a food and an important commodity, it was literally used as a mineral resource in places like this. A few years ago, we conducted a global study to try to assess the status of bivalve reefs around the world. And this slide, this map, shows you a summary of the findings there. The big message at the top is that 85% of the world's oyster reefs are likely gone. Now that does not mean that there are not many oysters being grown for aquaculture to feed people, but it does mean that the reefs that oysters in their native habitat once formed are largely gone and continue to disappear. So the red color here means that 90% of the reef that was once found in those ecoregions or more is now gone. And we think that that's a problem that the international conservation community needs to take up. In the United States, in the last 10 years or so, there has been a concerted effort to begin to reverse that trend. And as you might have noticed, the trend is very bad in the United States. Very, very bad indeed. So communities have been getting together to physically rebuild the oyster reefs that they once had in their embayments, literally shovel by shovel, making piles of oyster shells into small reefs that not only attract oysters, but they attract and produce fish that are of commercial and recreational and economic importance in the area. Importantly, we've been measuring progress and increasingly monitoring the results and the outcomes of these projects. And that's key because very recently we've been able to use those kinds of data about the ecosystem benefits of intact oyster reefs to take this to a much larger scale, an industrial scale almost. So these pictures here show a project in Alabama in the Gulf of Mexico that was funded a few years ago when the United States passed an economic stimulus bill that funded infrastructure projects, for example. In this case, it was coastal natural infrastructure where we used oyster reefs, literally turned mountains of oyster shells into